example 3 in 2.1 is just building some of the framework, I should say, sorry, for when we start to look at, different angles that have the same reference angle. And one of the easiest ways of finding those other angles that have the same reference angle is reflections. So if I were to take the angle, and they've drawn, 40 degrees for us right here, and they want us to reflect it across the y-axis. So that's that red dotted line, and I'm just going to draw the x-axis for B while I'm at it. If I reflect across that line, and I'm going to draw maybe the reflected one in black, then if I reflect that blue line, what's going to happen is it's going to look like a mirror image, which means the angle down here would be the same as the angle given to us. Now, what they want us to do is determine the angle, and this is really important, in standard position. So, and I'm going to write the formula and manipulate it. In quadrant 2, we finished saying in the previous example that theta reference is equal to 180 degrees minus the rotational angle. Well, what I can do is I can manipulate that, and I'm going to put then that theta plus theta r is 180, or the angle in standard position in quadrant 2 is 180 degrees minus the reference angle. So that means that that angle in quadrant 2 would be 180 degrees minus 40, which is 140 degrees. Now, some students recognize that immediately if this angle in black is 40 degrees, then the red angle required to rotate there has to add to 180. Which is really what we're doing algebraically. But what we can say, and I want to summarize it down here, is that 140 degrees and, oh, I spelled and wrong, genius, 40 degrees, they have the same reference angle. I spelled the wrong too, it's a bad day. Same, and I'll just put theta ref. That's really what these examples are kind of driving at, is by doing reflections, and I'll show it for B right away here. When I reflect it in the x-axis, it means that this angle is the same, right? That angle that, if you look at, putting your arm on a mirror at an angle, that angle that you see into the mirror is the same as the angle between your arm and the mirror. That's what a mirror image really tells us. So what we're going to do now is basically the same thing. And again, I want to show the logical concept. I'm going to do logical concept first for this one, that if this little angle in black is 40 degrees, a full circle, which is the red plus the black, has to be 360 degrees. So my red angle needs to be 320, because 320 plus 40 is 360. Now, again, I'm going to show that algebra that if we look at the formula for quadrant 4, my reference angle is 360 degrees minus my angle in standard position. So theta reference plus my angle has to be equal to 360, or the angle is 360 degrees minus the reference angle, which in this case, yielded 320. And I would like to add on then that means that 140 degrees and 40 degrees and 320 degrees have the same reference angle. But there's one more. And the way that we get that kind of fourth angle, because all four have a reference angle of 40, is we do both. We reflect in the y-axis and then the x-axis. And I'm going to try to show this with a couple different colors. So I'm going to reflect it in the y-axis with a green line. So when I reflect it across the y-axis, I get this, and that angle is 40 degrees in there. That would be the reference angle. And then what I'm going to do is I'm going to reflect it in the x-axis, which is going to give me that black line, and that angle in there is 40 degrees. Now, it is worth mentioning that if we did want to, I could say that, and I'll use maybe just A here for angle, those angles are equal as well. They would both be 50, but it's the angle from the terminal arm to the x-axis that we're worried about. Try not to really measure anything to the y-axis because it's just incorrect. All right, we are in quadrant 3, and I'll label the quadrants on this one just so we see it at least once. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 3, when we think about the formula, we get that our reference angle is the angle in standard position minus 180 degrees. That means that our angle is 180 degrees plus our reference angle. So in this case, the angle would be 180 degrees plus 40, which is 220 degrees. Now, the logical way of doing that is to think, and I know my diagram's getting a little busy, so I'm going to draw it in blue, that when we get to that black terminal arm, we've rotated through 90, 180, plus an additional 40. So 180 plus 40 yields to 220 with both techniques. Now, again, following this up and making that summary, I'm going to put underneath it here that we can say that 40 degrees, 140 degrees, 220 degrees, and 320 degrees all have, and I'll use the notation here, a theta r of 40 degrees. You will be asked a question like this. Make sure you know how to go from a reference angle to the 4 angles in standard position.